Assalamualaikum and good morning to everyone. I am Hazwani binti Ghazali from University Malaysia Perlis, and I would like to present about laccase biosynthesis using Bacillus Subtilis GK1 isolated from Perlis State Park. This research was funded by the Fundamental Research Grant Scheme FRGS, and my supervisor are Dr. Kunal Sundari, anak perempuan Balakrishnan, and Mr. Muhammad Farul Razi bin Tompang. I will begin my presentation with introduction. Lignocellulosic waste can be classified into two major components, which are polysaccharides and polymer. There are various methods that can be used to degrade lignin from a biomass, either chemically, biologically, or physically. In order to break down lignin in lignocellulosic waste, harsh chemicals such as sulfuric acid and sodium hydroxide are used at high concentration. As a result, one of the potential treatments is enzymatic delignification of this lignocellulosic waste using laccase, which is more environmental friendly. Let's move to the next slide. For problem statement, limited study on the thermodynamics of laccase-catalysed agricultural waste delignification reaction will enable us to gain the knowledge of this reaction pathway to maximize the yield of the desired products. Other than that, laccase have received a lot of interest from researchers. Thus, this study is geared to understand the underlying energy consumption in a thermodynamic study for the lignin deconstruction process by laccase from the locally isolated bacterium Bacillus Subtilis GK1. Lastly, to highlight the research gap about the limited study on the production of laccase from bacteria. Next, process flow and methodology. First one, analysis and molecular identification of isolated laccase secreting microorganism by preculture of Bacillus Subtilis GK1 in nutrient broth and minimal salt media. Then, laccase assay, protein assay will be used to construct the growth curve and enzyme profile. After that, screening for addition of glycol at different time of cultivation. Crude enzyme will be obtained using ammonium sulfate precipitation, followed by further purification using ion exchange chromatography and FPLC. Molecular weight of laccase will be determined using SDS page. And then, the Michaelis methane kinetic will be established using model substrate and lignocellulosic biomass such as rice straw at different concentrations. And lastly, the energy consumption in a component of thermodynamic research for lignin breakdown processes using laccase from Bacillus Subtilis GK1 will be investigated. Next part, we will discuss about result. As shown in the figure, glycol, a lignin-based aromatic compound, is the molecular effector for laccase. Oxidation-reduction reaction involving glycol by laccase of Bacillus Subtilis GK1 resulted in the formation of reddish-brown zone around its colony. The color reaction with glycol is the most widely method used for the screening of laccase production. Figure 2 represents a growth profile of Bacillus Subtilis GK1 in nutrient broth and minimal salt medium incubated at 37 degrees Celsius, 150 rpm for 48 hours. Based on the graph, the exponential phase of Bacillus Subtilis GK1 in nutrient broth started at 12 hours up to 24 hours of incubation, while exponential phase for minimal salt medium was observed to begin at 20 hours up to 32 hours. Bacillus subtilis GK1 has shown lower amount of bacterial cell production in minimal salt medium due to minimum nutrients were available to support its growth. The limitation of nutrient in minimal salt medium is necessary to induce stress to microorganisms to active bacterial laccase expression. Hence, minimal salt medium was selected for laccase production using Bacillus subtilis GK1 in this research. Let's move to the net result. Figure 3 represents the growth profile of Bacillus subtilis GK1 in minimal salt medium, supplemented with glycol at 0 hour as control and at 12 hour. The addition of glycol at 0 hour highlight the stimulation of enzymatic activity that contribute to the higher growth. The growth of the culture supplemented with glycol at 12 hour was lower in the first 12 hour. Upon addition of glycol, the culture started to grow at a rate resembling the culture with glycol at 0 hour. This clearly indicated that glycol addition has positive effect on the growth of Bacillus subtilis GK1 that could be linked biochemical mechanism in the cell. The addition of glycol at 12 hours is more desirable to stimulate the growth of the culture and in parallel could positively affect the laccase production. Table 1 shows laccase activity and protein concentration of Bacillus subtilis GK1 with addition of glycol and lignin during 0 hour and 12 hour. By comparing the tabulated data, the laccase activity with addition of inducer during 12 hour was higher compared to during 0 hour. In this experiment, it was found that addition of glycol at 12 hours has a greater stimulation on the laccase production, which corresponds to the time of action. Based on the observation, the higher the laccase activity, the higher the protein concentration. The protein concentration show increment up to 48 hours correspond with laccase activity of both cultures that supplemented with glycol at 0 hour and 12 hour. Last but not least, for novelties and inventiveness, utilization of laccase as delignification tool of lignocellulosic biomass gaining interest among the researchers. There is no research was carried out on thermodynamic properties of delignification process of lignocellulosic biomass to release hollow cellulose using laccase. The study of kinetic and thermodynamic properties of laccase-catalysed delignification reaction is a novel aspect that will be highlighted in this study. This knowledge is essential as it serves as a foundation for bioprocessing scale up from lab scale to pilot scale and industrial scale of enzymatic delignification. In addition, this will be a groundbreaking study on the identification of lignin-degrading microorganisms from Perlis State Park ecosystem.